So, like I said, there's going to be 9 of these we go through. Okay. Most of these are used for solving equations out, or like manipulating an equation. And I'll have these. They're not in order of any importance, just the order of what I kind of remember them as. All right, first one. Oh, and what we're going to be doing with these is, like I said, we're using this to kind of set up proof writing. And when you write a proof, essentially what you do is you solve a problem. And for every step of that problem, as you go through it, you write a reason why you're allowed to do that. So the things we're going through now are giving you like the reasons why you're allowed to do these specific things. So if you solve an equation, like if you add things to both sides or subtract or divide, these are your reasonings behind it. And you'll see in a second when we actually write it out like formally what I mean by giving you a reason for every step that you do. All right, so the first one is your addition property of equality. Okay. From this point on, if I have to write property of equality, I'm just going to write that, just for the sake of not having to write it every single time. Much easier to do. Okay, so addition property of equality. I'll write it out kind of formally and then maybe give an example, but when we actually do the equations, it kind of falls into place pretty easily. The way this is set up, and these I can write as like if-thens. So the way addition property of equality works, it says if you got 2 things that are equal to each other, in our case it could be variables, numbers, angle measures, whatever. But if A equals B, then if I add something to one side, A plus, we'll use C. Again, the letters are up there because you write this as a general form. I don't want to limit it to a specific number value or variable. So what this says, this is a property of equality, meaning I want to keep this statement equal. So if I add something to one side, to keep it equal, you have to add something to the other side. That's it. Okay, now for simple like balancing stuff, like with the way it looks there, it doesn't make much sense. The way you guys would use it would be something like, if I had that equation right there, if I wanted to solve this equation, what would you do with that too? You would add it, right? So in reality, what just happened there is you added 2 to that side, and to keep it balanced, you did that. That's what, if someone said, why are you allowed to do that? This would be your reasoning behind it. When you first started doing these equations, these properties came up, but like I said, you get to a point where you solve these out without much thought, outside of in your head saying like +2, you don't really give reasoning behind it. Okay, so this kind of has to go back to when you first started doing these equations. You probably should have done full reasoning, so it's going way back to when you did that. All right, so next one would be subtraction. Which again, the way we're using it is essentially if you subtract something from both sides to solve an equation or balance an equation or whatever, this would be your reasoning behind it. If I wrote it out in general terms, again, it would start with if 2 things are equal to each other. If I subtracted something from one side to keep it balanced, you have to subtract something to the other. Okay, but again, if I was doing this with like an equation, if I had x plus 2, I would subtract it to solve it. Okay, which essentially you subtract things from both sides. Third thing would be, so we got addition, subtraction, then multiplication. So these first 4 are just your specific operators. Operators meaning like addition, subtraction, multiplication, and then division. Okay, so this one would read, if I start with that same statement saying 2 things are equal, and I multiply one side by a specific number to keep it balanced, I have to also multiply the other side by it. And then the fourth one would be your division property of equality, which is basically the same thing as I had up here, just now you switch your operator to dividing. So then C, and you can add 4C doesn't equal 0 like on the end, just because you can't divide by 0. Okay? These are going to be the things you stick with most if you're solving any kind of equation, whether it be for angles or segments or if you're solving it and the directions say explain or give a reason for each step, these are things you're going to be writing out a lot of. Okay? All right, so here's the next one we'll do. Okay, the rest of them are going to be more of like manipulative tools. So the first one we'll do would be distributed property. Okay, this one, it's not necessarily of equality kind of thing. You can leave it. You can put of equality at the end if you want. Most people just leave this one with distributed property. So this one, if you forgot, this would be things like if you've got a number or variable or whatever on the outside of an expression. Okay, so if you had that on one side, remember distributive property allows you to take whatever's on the outside of the parentheses and move it to the inside by multiplication. So the distributive property allows you to, I guess I don't need an if, write it like that. So this would be, again, just a tool for solving out an equation if you needed it to be there. All right, it's not like a necessary tool, but if you can use it, then that's fine. Okay. All right, next one would be substitution property. That of equality. All right, so substitution property is the one that says, look, if you got two things that are equal, then they're interchangeable, meaning in an equation anywhere, if you see one of them, you can replace it with the other. So this would be used if you had things like, if it said like, x plus y equals 5, and they say something like, solve for x when y equals 4. Okay, and it's basically the idea of, look, I got two variables here, I can't solve that equation by itself. But if I tell you what y equals, you can substitute it into the equation. So that right there would be you applying this property. So if you got to this point and they say, why did you put 4 in there? You would say substitution property tells me I'm allowed to do that. And then you would do subtraction property to solve it out. So these are reflexive property, which will come up quite a bit in the next few chapters. Then there is, and I'm going to fill in below it what these are, but I'm going to write them out first. Symmetric property of equality, and then transitive. Okay. This one and that one are the ones that you're going to use the most of. Okay? The symmetric one doesn't come up as much. All right? Reflexive property, at its base, if I wrote it out in words what it is, it just says something like, I'll keep this horribly general, but something is equal to itself. So if I got two angles, or I got one angle, I can say it's equal to itself. So this is like saying A equals A, or X equals X, or B equals B, or something like that. Now, this doesn't seem like a property that is extremely useful, but when we start doing congruent shapes and having to prove that shapes are congruent, this is a very easy tool to use to say that you've got like a pair of sides or a pair of angles that are equal. So this will come up quite a bit, but this is simply saying something is equal to itself. All right, you probably won't use it much in terms of solving equations or solving problems yet. It's more of a probably chapter 4 is when we'll get into using that. Okay, symmetric property. This is the property that allows you to reverse sides of an equation. The only time this probably gets used is for the people that like to see variables on the left-hand side of the equation as opposed to the right. In general, you write this as if A equals B, then B equals A. So the only way people would have used this probably in the past would be if you were solving an equation and you got something that said like 5 equals x. There's people that don't like to see the x on the right-hand side, and this property is the one that allows you to write that as that if you get to that point. Otherwise, you're not going to use it that much. Okay? All right, transitive property, this is a way to kind of link 3 things together as equal to each other. For this property to work, what you need is you need to have 2 elements that are equal to each other. And then you also have to have another pair of things equal to each other, but you have to have an overlap from here, meaning if I start with A equals B, then I'm going to take B and equal it to something else. And as long as you have this happening where between the 2 equations here, the 2 expressions, I've got something that's overlapping, which in case is the B. And this property allows you to say, look, if I know all this is happening, then without any work, I can say the first thing and the last thing are equal to each other. This is, again, something that will come up quite a bit. This one probably in the next chapter quite a bit. All right, just because we're going to start working towards, we want elements of diagrams to be equal, like angles to be the same, segments. This and this are easy ways to link things together. Okay? And if you look at the progression here, this is like 1 thing equal to itself. This is 2 things equal. This is making 3 things equal to it. What you guys are doing now is going to be, we're going to be focused on at least the start of what proof stuff is. Okay? So I know I brought that up, and I've kind of mentioned in passing, like it's like an explanation. Basically, the work that you did yesterday with the little bit of logic that we did, the purpose of that is because to do a decent proof, not even if you don't get to the point where you can write these things perfectly, but to do a decent job, you basically need to have logical thought going on. So you have to have a starting point, an ending point. You got to be able to convey how you go from a starting point to an ending point, like every little step that needs to happen. For practice of this, what we're going to be working with today is going to be equations and even setting up problems that you would have solved out in the first chapter stuff. But now I've got a couple of theorems or postulates that you're going to have to reference when you set these problems up. But it's not going to go really beyond anything outside of like solving an equation out today. The last thing that's up there, the other thing that just popped up there, it basically says it takes trial and error, guys. It takes a lot of patience to get the stuff down. We're spending at least 3 or 4 chapters that are going to be heavy in terms of writing proofs, meaning like you'll do a problem, but you'll also have to have a full explanation there for it, which is what a proof is. All right. Now, the way you guys are going to set those up, can I go past this? Okay, I'll wait a second. There's multiple ways to write proofs. There's 3 main ways. I'll have it up there in a second. Just to correspond mostly with what geometry courses do, is you'll stick mostly in the form that it's set up as like 2 columns where you do work on one side and explanations on another. It's not the only way. It's really not the best way to do it, but most geometry books stick that way, so in most geometry tests will be presented to you that way. So we'll stick with that mostly, okay? So the three main ways are going to be this one here. So 2-column is the one that I said is the most common for geometry. Again, what this comes down to is on this proof, you'll have like the statement portion, guys. This is where you do the work. Reasoning is where you put your explanations. This right here, anything that I've already referenced as a postulate or a property or a definition, that goes here. So the addition, property of equality, if we use that, it goes on this side. Substitution, multiplicate, whatever. All right. You don't have to copy down exactly what's within here right now. Just understand that this thing is called a 2-column proof. The left-hand side is titled statements. The other side is titled reasons. And understand statements is where you show your work. Reasons are you're given the reason why you're allowed to do that. Okay? All right. So just to get a feel of what this would look like, what we're going to do is I'm going to do 2 of these where it's just going to be an equation. And it's simply going to say solve the equation, but to give you a little bit more work involved, it'll say solve an equation and then explain each step. What I'm going to do now, you only have to do if the question actually says explain each step. If it doesn't say explain or give a reason for each step, you don't need to go as in depth as the setup I'll have now. Okay? Like if I give you just an equation and say solve for x, and that's all I say, just solve for x. Don't give like reasons and all this stuff for it. So first one I'm going to do is this one, and then we'll do one more after this. Right, so again, I've got an equation up there. I'm going to solve the equation, but since I also have the thing saying explain each step, I'm going to set this up as like a form of proof. Okay? So the way you do this, and this would be the only time I really tell you stick to one type of proof. So the way I'm going to do this is I'm going to do it as a 2-column. So that means I want this set up as statements on one side, reasons on the other. And again, I'm doing this simply so that you can get a feel of what these look like and a habit of writing all the work on one side and your reasons why you're doing that work on the other, or what allows you to do those steps. When you do proofs, you generally, your first step is going to be what you're starting with, which is called what you're given. So in this case, I'm starting you with an equation. So when you do the problem, you copy down, that is 1, right? Yeah. The equation that you have in the first step, and you state that as that's my starting point, which is just your given. Given just entails that that's what they're providing you in the problem. Then you just go through the work. All right. Usually, now here's the trick with this is you got to show every little step. Don't combine steps. Don't skip over things. Don't assume people know what's going on. That's where people have big issues with writing proofs, is they skip little steps. Okay. So this will probably take like 3 more steps to actually get down to the end. All right. The order you do this in doesn't matter as long as you can back it up with the property. So what should I do first to solve this?
Plus 4x.
So plus 4x. So if I do plus 4x to this side, this will create it as 9x plus 1 equals 28. Okay. You try not to actually show the work. You want it to look nice and neat, so you just kind of show the result of what you did. All right. Now, over here, you're writing the reason that got you to this step. So since you said plus 4x, that means that the property I put over here has to be addition, property of equality. Okay? Then what would come next? Subtract 1. So again, I'm just going to write the result. I'm not putting actually minus 1 there. So I don't have to put -1 there because over here I'm going to say, look, I use subtraction. All right, to get there, so I don't have to specify it with the work. And then the last thing you would do is what?
Divide.
So what's 27 divided by 9?
About 3.
And that would be division. Okay, so now look, this would be a very basic setup for a proof. This is what proofs will look like. You'll have your work on one side. You'll have the reason why you're doing stuff on the other side. And again, guys, with equations, you only have to do all this if you see like explain each step or give a reason for each step. If it just says solve for x, just solve for x. Don't do all this other stuff. All right, so just like the last one, first thing I'll do is I'm going to rewrite the actual problem I have there. -4x. Okay. Now again, like the order I do this in, it doesn't matter as long as what I do to get to the next step, I have some kind of reasoning behind it, something that actually makes sense. What are you going to do first? Distribute what? The -2. So if I distribute the -2, that'll give me -2x plus 2, 4x. So you said distributive. Okay. Now what?
Add 2x. No.
You want to do that? I can do that. That's fine. You want to do that?
Yeah.
Add 2x. Okay. So this would be what? 8 plus 2. 13 minus 2x? Yeah.
It's add 2, so it'd be.
So you added that, so it's addition property of equality. Okay. Now what?
Divide by 8.
Okay. When you do this, like I'm only doing work over here. So when you say combine 8 and 2 to make 10, what you're essentially doing is, since you're only doing work on one side, it's not addition property. Addition property of equalities tell me I did it to both sides. Anytime you combine like terms, you can write combine like terms if you want. It's just easier to write simplify or simplification, because that's what you're doing. You're simplifying the equation. So this is pretty much a short way to write combine like terms. Okay, so if you get to a problem where you're doing that, you combine like terms, just put simplify. Now what?
Minus 13.
So that'd be what, -3
Yeah.
x. So subtraction, because you subtracted that. Subtraction. Quality. And then the last thing is what? Divide by -2, so that would give you a 3/2. You divide it by 2, the 2 better be on the bottom. And that's fine. If you wanted to, if you wanted to add that one more step and reverse it so you got the x on the left-hand side, you can add symmetric. I still get to waste the step, but whatever. Okay? Some people like to see it that way, and that's fine. Okay? So is the basic premise kind of there right now?
Yeah.
Sure. Okay, so is now the reason why you're going to be allowed to show that these things are equal to each other. So it's basically going to take the problems you already did and add just a little bit more to it, because now you'll do the problem and you'll set the problem up like you would, but you'll have a reason that goes with it. So again, if I gave you, like this right here would be a problem that you would have had in the first chapter. It just wouldn't have had that portion of it. All it would have had is, here's a picture and it would say solve for x. Okay? So to kind of tie it into what you're doing now, which is an introduction to proof writing, it's going to be the same type of problem where it's going to say solve for x, but it's going to say, okay, now solve for x, but give me a reason for each step, meaning I want this thing set up in kind of the 2-column form I just had. So it's taken what you would have already had to do, which the process you already would have gone through is those 2 lines are straight lines crossing. These 2 angles right here are vertical angles, which means that those angles are congruent. Okay, and that would have allowed you to set the problem. So you actually doing this problem, which would start with 3x equals 40. That would have been the same setup you did the last chapter. Like I said, the difference is now, if you actually write this out as this is the equation I'm going to work with, you have to give a reason for it. Okay, and I kind of mentioned it that anytime I give you something that's like a theorem or postulate, property, these are going to be the things that get stuck over here for reasons of why you're allowed to set this up. So if I was doing this problem now, I would say, look, these 2 things are equal to each other because, what's it say there? Because of the vertical angles theorem. Okay, that's what allowed me to set it up. That theorem says they're equal, well, congruent, equal. So now I'm using that theorem to set the problem up. And then you would go through the act of actually solving it out, which to solve this equation out, what would you do?
Subtract 2x.
If I subtract 2x, that'll leave me with x equals 40. So it's not a longer problem. Like this added one more step to really what you would have been doing, or well, 2 more reasons. But this would now be like a complete explanation for doing that problem of solving for x. Okay? Now again, you're only doing this if it's giving you the idea that says explain each step, or give a reason for each step. Just explain. If you don't see that there, then you can just solve for x like you would normally do. Okay? So like what this says up here, we've already talked about. This is just putting a name to it. All right? Yeah.
So that, like, instead of saying given, you put 0?
Yeah, because your given's a picture, so I'm not going to like draw the picture and say it's the given. If they give you, if there's like words for the given, then you would rewrite them. But if it's like in the diagram, it's kind of known that the diagram has to be attached, so it's just kind of there. Okay? Hey, with any of these, if you see the numbers there, like theorem 2.1, that doesn't matter. You don't need to write the numbers down. The things that'll matter is if it has like a name to it, like vertical angles theorem. Okay? The numbering, the way the numbering works is it's the 2 stands for chapter 2, and the 1 says it's the first theorem in that chapter. So it changes with each book. All right? Next thing. Okay, now again, look, we've already done linear pairs. It's a pair of angles that makes a line. We've done that. They're next to each other. If it makes a line, how many degrees are in a straight line?
180.
180. So I know a linear pair has to add up to 180. But again, now I'm going to put a name to it. Linear pair postulate is giving you a name so that you can set a problem up, and you can use that name as now a reason. Okay? So again, you're going to be solving problems out where if it said solve for x, give an explanation for each step, then you would set your little table up, you would do your work on one side, reasoning on the other. So anywhere that if you saw linear pair, like these 2 here, right, these 2 right here would be a linear pair because that's a straight line. Therefore, there's 180 degrees in the straight line. So if I went through the act of actually setting this up, meaning I would take these 2 angles right there, right, the 3x plus 10 and the x minus 30, and set them equal to 180. And if someone said why, instead of going through this explanation of they're a linear pair, which means they make a line, which means there's 180, and I'm putting these together because of blah, whatever. Yet, you know, that's a long-winded explanation. So instead of going into all that, you would just say Linear pair postulate says I can do that. End of story. Okay? Most of the time, these postulates and theorems, guys, are going to give you like shortcuts to kind of long-winded explanations. Most of the time, you don't even realize it's happening, but it does. Okay, so what's up there is just your first step to setting it up. After that, it would be the properties that we talked about today: addition, subtraction, that kind of stuff. How do I got to solve this? What do I got to do? Well, if I simplify, what's the result? 4x.
I guess you can simplify both.
Well, if I'm using the same thing, I could do them both at the same time, and that's fine.
Yeah.
What was the other one?
So
Minus 20. Okay. So simplify. What would be next? If I add 20, what's that give me? So it's addition. Then what? Division.